All right, here we go. An angle, let's do this. I'm going to underline the word angle, let's define it. Here we go. I'm going to write the space in between two rays. The space in between two rays. In geometry, a ray is kind of like a line that starts somewhere and goes on forever. So notice this ray where my finger is at. It starts here at point A and goes on forever. It's got the arrow. And then another ray starts at point A and goes on forever. It goes that way. And the space in between, right here, this space is called the angle. That's what the angle is. It's the space in between two rays. The vertex is actually the point where the two rays meet. I'm going to put an arrow from the word vertex to point A. I trust you guys are with me so far. So we got vertex. We got this, the definition of an angle. We have our earphones off, so I'm going to give you a second snap. Phones away. All right. What about the sides of an angle? The sides are actually the rays themselves. I'm going to highlight the sides in Dodger blue because they're going to win the World Series next year. Right, Valdez? Next year. So look at that first ray that I highlighted in blue is one of the sides of the angle. The second ray is right here that I'm highlighting in blue also. So let's name the two sides to the two rays. Notice the way I'm going to name the ray. Ray AC, going to put AC and put a little ray symbol. And ray AB, another ray symbol. That's how we talk about rays in geometry. They begin and they go on forever in one direction. So the sides of the angle are the two rays I highlighted in blue. So far, so good. Now, when we do mathematics and geometry, we have to talk about angles. If you and I want to talk about an angle, we got to be speaking the same language, so there's conventions of how to talk about an angle and how to name an angle. And we're going to put it right under here where you wrote the words how to name an angle. I'm going to give you 3 ways to name this angle that you and I just drew. There's 3 different ways. Here's how we name it. The first way is use an angle symbol. It's like a little bent L. It's an angle. I'm going to name it just by its vertex, which is point A. So I can call this angle, like this way, you with me, right? Angle A. Boom. That's one legitimate name for the angle. Now, I can also name the angle using what we call a 3-letter method. 3 letters. I'm going to use 3 letters, but I'm going to ensure that the middle letter is the vertex letter. Watch this. I can also name this angle this way. I could call it angle BAC. Write this with me. Notice how the middle letter was the vertex. Or I can name it CAB. Notice how the middle letter is the vertex. Sometimes in textbooks in geometry, you'll see a 3-letter method of naming an angle or just a 1-letter method. All of them are legitimate and equally valid. That's how we talk about angles. That's how we name an angle. All right. Moving right along. Here we go. The interior of the angle is the space, the space in between the two rays. The space in between the two rays. So I'm going to highlight the space in between the two rays in red here. This is the interior, all this space here. Matter of fact, I'm going to color the interior just a bunch of red here. All this is the interior of the angle. Notice. It goes on forever because these rays go on forever. So what I'm calling in red is the interior of the angle, and the exterior, obviously, is the space outside the two rays. The space outside the two rays. So the space outside the two rays is too much space to color, so I'm just going to like do it with an arc. All this space right here outside the two rays is the exterior of the angle. Notice that big loopy arc I did? All this space outside the two rays is the exterior. Interior, exterior. We're rock and rolling. Go for it. All right, here we go. What's the next word? Someone read it up. Measure the angle. How do we measure angles? Check this out. We don't measure angles in feet. We don't measure angles in inches. We don't measure angles in seconds or hours. The way we measure an angle, watch this. What kind of units though? Right. So technically you're actually right. Units are, that's just a general term for measuring anything. So miles is a unit. Over here, please. Inches are a unit, feet are a unit, seconds are a unit. They're all units of measure. My question is, what units of measure do we use to measure angles? In other words, what are these called? Look at it. What are these, all these little tick marks called? Good job, Rios. What kind of numbers, though? Miles are numbers. Seconds are numbers. Well, what are these units called that a protractor, which I'm going to pass out shortly, check this out. Why are you criticizing me? You're making me feel really good at the future. That's wonderful. Thank you. Does anybody remember from maybe a past math course what these are called? Here's what it is. Nice. And what is each tick mark called? Here we go. So the measure of an angle is the, here we go, write this down, the degrees. The degrees of rotation, all right, here we go. The degrees of rotation measured by a protractor. By a protractor. Now, a protractor is these devices that we use to measure an angle. Let me show you what I'm talking about. The degrees of rotation measured by a protractor. So, watch Mr. Munguia use his protractor. So I'm going to pass these out. I'm going to use this protractor to measure the amount of rotation of this angle. This space in between the angle is measured in degrees using the protractor. So look what I'm going to do. I'm going to place the vertex, that vertex right in this hole where the cross is. And what I'm going to do is one ray, I put it right along the 0 degree mark. There's 0. And then the other ray, I'm counting the inside numbers. Notice the inside numbers start at 0, 10, 20, 30 degrees. Here's 90 degrees. And it ends around 140 degrees. Notice I didn't use the outside numbers because the outside numbers started at 180, which means I will use the outside numbers if I'm going to start over here. Here's 0, 10, 20. So it just depends on the orientation of the angle. The angle can be rotating this way or can be rotating this way. It doesn't matter. It's still the same size. Let me demonstrate. So right now, I use the inside numbers. It became 140 degrees. So this angle, you don't have to write this down. this angle is approximately 140 degrees. Approximately. Every time you're using a protractor, you have to use the approximate symbol because you may have had a slight degree of error in applying the measuring instrument. Every time you measure something, there can be a slight human error. You always use approximate, never equal. There's always some degree of error when human beings apply certain measuring devices to any situation. So notice, I use the inside numbers. What if I want to use the outside numbers? Check this out. Let me rotate this puppy. So I'm going to use the outside numbers. Watch this. I'm going to put the vertex right here on the hole. Let me talk, please. Excuse me. Thank you. So I'm going to put this ray now along the outside 0, and I'm going to count the outside numbers, 0, 10, 20, and it's still 140 degrees above. So it doesn't matter. If you want to use the inside numbers, knock yourself out. You want to use the outside numbers, knock yourself out. They're both the same. They're both the same. It's just all talking about rotation. So it's still 140 degrees. Look at the outside numbers, there's 140. Now, have those notes out. What's the next word there? Acute angle. The video is going to define it. So have your pen ready. Let's play the video.
Hi, welcome to Math Antics. We're continuing our series on geometry, and today we're going to learn about angles. In our last video, we learned about points and lines, and that's good because we're going to need lines to make angles. So let's start with a couple of lines that are in the same plane. We're only going to be dealing with two-dimensional geometry in this video. These lines are conveniently called line AB and line CD. Now, the important thing to notice about these two lines is that they're pointing in exactly the same direction. So even if we extend them forever, they would never cross or even get closer together. When two lines are arranged like this, we call them parallel. Now, you've probably heard the term parallel before, like parallel parking or a parallel universe or parallel bars. Okay.
Wasn't that funny?